Okay, hi class. So from today, let's start discussion of equilibrium of the rigid bodies. So far we have talked about equilibrium of the particles. So particle in static class, which means it has no size. So as long as you have one particle here, you have F1, F2. So how to make the particle in equilibrium status? We just make sure sum of fx is equal to 0 and the sum of fy equals to 0 if it's a 2D case. So from today, we will discuss the equilibrium of the rigid bodies. So rigid body, it has size. So forces on the rigid bodies, they are not concurrent. So which means the forces could make the rigid body has some rotations. So for example, we have x and y. Here is the rigid body. We have F1, F2. Okay, it could make this rigid body rotate. So therefore, we definitely need some extra equations to make a rigid body in a stable status. So to make a rigid body in equilibrium, sum of the F equals to 0. Net moment should also be equal to 0. Sum of x equals to 0. To be more specific, sum of Fy also equals to 0. And sum of the m equals to 0. Okay, so the top two equation makes sure our rigid body has no transitions, and the sum of the m equals to 0 makes sure our rigid body has no rotations. Okay. So free body diagram. Okay, from today we will also start practice draw a free body diagram of the rigid body. So the free body diagram should show reactive forces and also the geometry of the rigid body, and then we apply our equilibrium equation of the equilibrium to solve the problem or solve the unknowns. So before we discuss the unknowns for roller, pin, or fixed support, for the rigid body, we have three equations of the equilibriums, which means we can solve at a maximum three unknowns. Okay, please keep this in mind. Reactive forces. So let's say we have the beam. This side is a pin, this side is a roller. Okay, for the pin, it has two reactive force, okay, in both fx and fy direction, but for the rollers, it had only one unknowns, which is fx. Which is fy in the y direction. Okay, because the roller cannot provide any support in the horizontal direction, so which means it can only has reactive forces on the vertical direction, which is the y direction. Okay, for the roller and the pin. What about fixed? Okay, fixed support. So for the fixed support, it can provide not only the force fx and fy, it can also provide a moment. Okay, so which means for any fixed support, it has 3 unknowns. For the pin, it has 2 unknowns. For a roller, it has 1 unknowns. So for rigid body, we have 3 equilibrium of equivalence. We can solve at the most 3 unknowns. Okay. So here is the figure showing all the reactive forces. We can see here is a roller. It has only 1 force. Pin or hinge has 2. Fixed support has 3. Okay. And then we need to know how to draw the free body diagram from the real world cases. So for example, you are given the unloaded platform which is suspended off the edge of the oil rig. The platform has a mass of 200 kilogram. So please draw an idealized model and a free diagram of the platform in 2D. Okay. Here's the platform. How to draw a free body diagram from this real world case. So the connection A, okay, can be treated as a pin, and the cable supports the platform at B. Okay. So the G, okay, let's assume G is the center of gravity of this platform. So we can draw the tension T is in the direction of the cable, and A point is a pin at AX and AY, and the G is the center of gravity. It has here is the self weight, okay. And also here is the geometry of this platform. So after drawing a free body diagram, okay, we can solve this problem. So we have 3 unknowns, AX, AY, and T, and here is and we have 3 equation of the equilibrium, so we can solve this problem. So what about this one? How many unknowns are in this system? As we know, A is a pin, AX, AY, and also we have T tension, TBD, and tension TDE, and C is a self weight, okay, of the 80 kilogram load. So looks like we have more unknowns, which is 4, than the number of the equation of equilibriums. It seems the problem cannot be solved. So how many of you agree with this problem cannot be solved? Because we have 4 unknowns, but we only have 3 equations. Okay, how many of you agree with this statement? So however, one thing, okay, is different in this equation is tension BD and tension DE, they are from a same cable. So if you have a cable, no matter its shape, okay, if you cut a cable in different cross section, the tension in different cross sections should be the same because it's the same cable. So which means instead of we write down TBD and the TDE, we can just write down the T as the tension because it's the same. So in this way, this problem has only 3 forces. Okay, so and also we have 3 equations. The problem can be solved. Okay, does this make sense to you? So another one, concept quiz. So we have a force here. We also have a moment here, and a point A, by, bx, also ay. So what if we change the moment to this direction, change the force to this direction, so the object will be lifted from point A, okay, because point A is a roller, it can only provide the forces which push the roller up, okay. It cannot push the roller back, okay. It cannot hold the roller from rotation, so which means the beam will be lifted from point A. Example 3, how to draw a free body diagram of this smooth pipe. So the smooth pipe means there is no friction here, A and B. And C, okay? But there will be some support force here. Here the idealized model. Here is the free body diagram, okay? So because it's a smooth pipe, there is no friction. It only has a support NA, NB, and NC at these 3 points, okay? What about this one? How many anode support reaction are in this problem? Okay, point A is a fixed AX, AY, and the moment. Point B, roller, only has BY. So we have 3 forces and 1 couple moment. So well, that's pretty much for today. So the thing discussed for today will be used for next lesson to solve the problems.